refresh of what HP Labs is and how we are organized. And so as a central research arm for Hewlett-Packard, we are responsible for looking at research into areas that will be important to customers sort of 3, 5, 10 years into the future. Collectively, we have over 500 researchers in 7 locations worldwide. About the majority of our researchers are located right here in Palo Alto, but we have significant presence in Bristol, in England, in Haifa, Israel, in St. Petersburg, Russia, Beijing, Bangalore, and we just opened up a lab in Singapore last year. So collectively, these researchers work on a lot of very exciting projects, about 24 research projects around 8 themes, which I will actually mention. But we also partner with lots of organizations outside HP Labs in a program called Open Innovation. I'm going to kind of just mention it to this audience. There are people from academia here that I just wanted to bring this to your attention, that every year we fund programs at universities, about 60 universities worldwide, and that sort of, it talks about who we fund in Europe, who we fund in Asia Pacific, who we fund in the US. And also we have programs going on with various locations in Mexico, in Brazil, and other locations. So we practice open innovation where we partner with organizations outside HP Labs to do interesting research that hopefully will turn into products and services for the company. At HP Labs, we have for the last 5 years been working on a set of research projects, so about 20 research projects, on trying to work on sort of in general 8 themes which we think are going to look at all touch point of information. We live in an information age, in an age where by the next sort of 8 to 10 years, by 2020, we'll be creating 50 zettabytes of information. That's 50 trillion gigabytes of information. So we need to do research on how we collect information, how we process information, how we transmit information, how we analyze information. And these 8 areas of research around sort of printing and content delivery, around mobile and immersive experiences, how through mobile devices you can actually access information, through our work on cloud and security, how all these information will be available to users through the cloud in a secure manner, how through our work on information analytics, we'll be able to analyze data, both structured data, unstructured data, live at the speed of business from the cloud, our work on intelligent infrastructure, which I'm going to talk about briefly in a moment, work on networking and communications, sort of future of networking through flexible networking and photonic interconnects, our work on services and solutions, and finally our work on sustainability, reducing energy consumption, reducing carbon footprint for all of society. So we have a very, very ambitious agenda, but what I'm going to do today is to talk about one of the areas around intelligent infrastructure, because that, I think, is going to be extremely important and relevant to today's audience. So what are we doing in the area of intelligent infrastructure? HP, as a very large IT infrastructure company in the world, we at HP Labs are looking at, so where is IT infrastructure headed? Briefly stated, our work in the IT infrastructure area deals with all sort of touch points of information, how you collect data, how you process data, how you transmit data, and how you analyze data, and how you store data. So essentially, we have a very ambitious research agenda around different areas. There is about 5 research projects. We have work going on in the area of next generation data centers. We have work going on in photonic interconnects. These 2 I'm going to talk in just a few minutes. But in addition to this, we have some very exciting work in a project called SENSE, which is Central Nervous System for the Earth, a vision where all around us we are going to have billions of trillions of nanoscale sensors which will try and replicate the 5 senses that we humans have. We see things, we smell things, we touch things, we hear things, and so all the things that we humans do, we are trying to replicate at the nanoscale level, collecting all this data through these sort of 1.3 trillion sensors, and then driving it to do very interesting sort of applications in terms of business insight, in oil exploration, to security, to sort of aircraft structures, and so on and so forth. We also have some work on storage, and storage work at the sort of device level, HP Labs researchers invented a device called the memristor, which is a form of non-volatile memory, somewhere between sort of a DRAM and a disk memory, and it's kind of essentially the idea is it's a passive element, it's a two-terminal element. Normally when you have a resistor, when you pass current through it, the resistance is kind of sort of fixed. But in a memristor, depending on one state, it will provide you a resistance of say 1 kilo ohm, and in a different state will provide you a resistance of 100 kilo ohm. And it is passive, so essentially it remembers the memory, and this is a form of very exciting non-volatile memory work that is going on in labs. The other work is on scalable storage, on cloud level storage, when you have petabytes of information, zettabytes of information, how do you store it in a scalable way, in a reliable way on the cloud? So we have a lot of very exciting areas of research in this topic. What I'm going to do is to first introduce a topic which is very relevant to DesignCon, which is our work on next-gen data centers. And why that is relevant is because as you look at the server architectures of the future, as you look at data centers, if the whole world is going through some very, very significant change, there are three dimensions of this change. The first thing is the kinds of workloads that will run on those data centers. Gone are the days where you run these very high-performance computing, computational fluid dynamics things running on, which require very, very expensive, very powerful computers as a compute nodes, and then scale up maybe tens of thousands of these high-performance computing processors. Instead, the workload is going towards more web-centric, data-centric, kind of embarrassingly parallel, but lots and lots of data being needed to be accessed. So the workload is going to be different. Second is the expectation around low power consumptions and so on and so forth in manageability and virtualization and so on. And the third thing is a move away from the conventional architectures, which are these very high-powered CPUs, to sort of a vision where you will have lots and lots of low-powered CPUs. The CPUs that run on your mobile devices, on your smartphones and so on, will be used in sort of future servers. So we are looking at very exciting research areas in topics called the nanostore, where by having lots of sort of petabytes of data stored in memory elements like the memristor, which will be non-volatile, so you don't have to have a DRAM and then a backup as a disk drive. You essentially have a tremendous amount of non-volatile storage, and now right next to these non-volatile storage, you'll have lots and lots of low-power processors, the processors right next to the storage. So that's kind of the architecture of the nanostore, and these nanostore sort of compute devices will be connected through photonic interface. So that's kind of a vision of the future that we are working on at HP Labs. And towards that vision, last year, in November, we announced a kind of a product vision from HP in a thing called Project Moonshot. Some of you may have heard about it, using low power processors from ARM and sort of Intel to drive low power servers. But that's just a step towards the vision. The grand vision is nanostore. So that is enabled by this photonic interconnect technology. And so I now want to introduce the main topic of today's conversation around photonics. So if you look at DesignCon, all the sort of cool designs that you do on computers today, they use electronic interconnects. Now, in the IC industry, people use sort of copper and aluminum to do these sort of transmitting electrical signals from one point to the other. Copper interconnects now can run at 10 gigabytes per second. So if you look at bladed servers and electronics and all those kind of stuff, we are pushing the limits at between 5 to 10 gigabytes per second. But if you look at the computational requirements, if you do just a simple search on Google, right, you type up a couple of keywords, it will result in 1 million bits of information being accessed. So as you do more and more complex stuff, the needs for transmitting data, communicating data increases thousands of times. So to get to those things, essentially copper interconnects are not going to work, right? It's going to sort of run out of gas, and it will take tremendous amount of power, and therefore the need for photonic interconnects.